Hello everybody, welcome to another Unity game development video. This is the second time I'm recording it because NVIDIA GeForce Shadowplay is a load of shit. It fucking sucks, and it likes to update and not record things because it has an update, which is really silly and makes me not like them very much. But I digress. Forget about that for now. We're going to talk about my third-person character controller, specifically the camera controller in this game, and specifically within that, we're going to talk about the way that the camera works when it would normally clip through objects in the scene. If I were to move a camera, if I just press play, something that you probably know about in a lot of games, and a lot of games that you've played you might take for granted, is that the camera will move into position so that it will not clip through an object. So if I rotate this camera right here, as you can see in the game view and the scene view, it kind of zooms in so that it doesn't go through the physical geometry of the object. And that's something that you're probably very used to. I would say 99% of third-person games will do this automatically. It's not something that's built into Unity. I had to code it in, and that's not a dig at Unity. I really like that everything you have to do in Unity you have to do, unless you're some kind of weirdo who just gets game packs and stuff like that and makes a hodgepodge Frankenstein game. And yes, that is a dig at people who do that, not a dig at Unity. It's something that you have to code into the game, and it's very common. I can probably only think of one game that wouldn't do something like this, like a Big Rigs Trucker game or something like that. But yeah, so this is something very important if you're ever planning on making a third-person game, and I didn't watch any tutorials on how one might do this, but I think that there's some very obvious logical conclusions that we can make, and with a little bit of understanding with a few of the built-in functions in Unity, we can understand something like this. And if I just look into, if I just go into the component in the inspector here, and I toggle this debug ray that I built into it. If I just click that, and you can see up in the game scene now, if I turn the camera over to this building that's obstructing it, you'll see that everything that's obstructed, the ray leading up to the obstruction is green, and everything past that is red. And that's just a nice visual illustration of how this system is working. Let's just move over to this wall I've put in place for this very example. And what I'm going to actually do is I'm going to take the camera and I'm going to specifically focus on that so you can see it moving. So, I got to reactivate the debug ray. Let's focus on the camera again. And press play. Now the camera's moving. If I go over to this wall, and if I zoom out, the camera's quickly lerping to the position of this hit point. And that's very simply being done with some ray casts. And I put these rays in place just to kind of illustrate that the natural path of the ray cast is being obstructed, and the hit point of it is being set for the new position of the camera. And if I just get out of here and I go to the code for this, I can further explain it. If I just go to the very top, we have a few variables here, some global variables that are interacting with these functions. And that is a bool telling you if the view is obstructed and the camera should be moved. An obstruction camera position, that's just the vector 3 location of the hit point so that the camera can be moved if it's obstructed. And these debug ray options, and that's just for those ray casts that were there. These are just debug feedback things for me telling you what's going on. So this debug source to camera length is the length of the ray from its source on the character towards the camera, but hitting what is it called? The obstruction. and this is the second variable going from the obstruction to the camera target, where the camera is originally trying to lerp to. So if we go down to the fixed update and we see this detect obstacle function here, and we'll just scroll down to where it is. The first thing that's going on is there is a float ray length, and that is being generated from a vector3 distance function, which is grabbing the distance from where the camera is trying to look to where the camera is trying to move to. And we get this ray direction because you have to input a direction, a vector3 direction for the ray. With simpler scripts, or very commonly with scripts, it'll just be vector3.forward or down or something like that for detecting floors. But in this case, we have to do it directly towards the camera. So what we're taking is the camera position and the camera's target, and we're subtracting the two, and that's how you get the vector between them. And I'm establishing a raycast hit variable, and that's just so that we can receive information from the raycast. So using some logical operation with an if statement for the raycast, we're just outing that hit, and here's the debug information. That's pretty straightforward. And if the hit is not tagged with player, so the reason we do that is if we get close enough to the player, what's going to happen is the ray is going to start hitting the actual player model, and the camera is just going to loop in a little spastic way until it's moved away or the camera is rotated so it can return to its original position, and that's no fun. And does the object that's being hit have a mesh renderer? Because we don't want the camera detecting invisible walls or empty objects as true hits. So if it passes those checks, then view obstruction is set to true. The obstruction camera position is equal to that hit point. So the hit point is exactly where the raycast is interacting an object. So it's where it's actually hitting the surface, and we can actually grab some information from that. In this particular instance, we're getting the vector3 position of it. We could actually grab the normals and other things like that from that. And if the raycast is going, if the debug ray is activated, we'll get that green ray up until that point and the red ray after. If the view obstruction is false, then we get that green ray all the way through. And you might notice there's no kind of coding here for moving the camera. This is just for grabbing the information that is later used. If I grab this view obstruction thing right here, and I scroll up and we find it, we actually have the logical operation code in the camera move function. So if the view is not obstructed, then the camera is going to lerp to that target position that it always tries to go to. But if it is obstructed, it's going to lerp to that obstruction camera position, which is just a global variable that's grabbing that hit point position. And that's about it. I think it was a very straightforward and a logical conclusion to make, to kind of create this code and do it this way. I don't know how anyone else does it. I'll probably look into that in a bit because that sounds interesting. But this is the way I did it, and I think it makes a lot of sense. I don't know much about optimizing functions and optimizing games, so maybe this might show some issues down the line. I don't see why it would, but I think this was an interesting way to do it, and I like it. If you thought that this was an interesting video, if you liked or thought the information would help you in creating your game, let me know in the comments. If you have any questions, let me know in the comments. Like the actual video, favorite it, share it around, and most importantly of all, subscribe to the channel, because I'm going to be making videos in the future. I'll probably always be making videos because I think it's a really great way of self-expression and getting kind of the stuff you're working on out there. And just subscribe. I don't know. That's it. Just subscribe. I'll also be making some Halo videos in the near future, probably after Christmas, because Christmas is pretty busy. Won't have a lot of time to get a bunch of videos out there. But thanks for watching, and I'll see you in the next video. Bye.